I've come to Gibraltar, to Gorham's and Vanguard Caves, which are two of the most exciting sites right now for Neanderthals and understanding their lifestyles and how they lived. So we're here at the very end of Europe. We're looking at two caves that were occupied at the end of Neanderthals' time, and it's an amazing place. I hope you like it.
What are we looking at?
Right. If you like, this is a cross-section of a dune. Can you imagine a sand dune that is being built up as the wind brings up little grains of sand, yeah? And it comes and it's sort of eddying in round structures that might be stalactites and that sort of thing. So it's not coming in straight, it's coming in at angles, and depending on how the dune is forming, the angles are changing.
Yeah.
The reason I'm saying this is that is what allows us to understand why you've got a almost horizontal level here, and then it starts sort of going upwards a bit. And you can actually follow this dark line quite clearly. Now, if you notice, this dark line is made up of charcoals.
Yeah.
But these charcoals, if you look underneath, the levels, the sediments underneath haven't been altered by heat. They're the same color and they're quite uniform. So our interpretation is that this charcoal is sliding down the dune, probably from a level a little bit further up, which we can look at in a minute. And, as the wind is bringing other sand grains along, it's also blowing these bits of charcoal, which are quite light, and they're accumulating here. But you can still follow, it seems to be on the lower area, there's more of them, but you can follow this level with these bits of charcoal.
So what we're looking at, just to make it really clear, is we're looking at an ancient surface, a floor surface in the cave, and people were active on this surface, and the charcoal is here because they were making fires.
Somebody was making a fire, and although you see a lot of it here, it doesn't necessarily mean that the fire was here.
Right.
However, if you come along to this part, you can see that underneath the charcoal here, you've got a very dark, rich colored area. And that shows alteration through heat.
Right.
So we have the hearth is actually here in this area.
Okay.
So now we're beginning to build up what this looked like when people were actually stepping on these levels.
Yeah.
They had their hearth here, and then after they'd left their hearth and it had cooled down, the wind was blowing everything around, and there were eddies, and it was accumulating in other parts of the cave. So you have to be aware of the geology to understand and interpret what you're finding when you do an excavation.
Sure, it's a track of behavior.
Exactly.
There was a fire, but that fire is there, it's left, there's charcoal left in it, you guys are finding things in the charcoal, and yet, after that fire is dead, people come in, they kick the charcoal around, there's, animals are coming in, it has a life of its own before it gets buried.
That's right. And when we come back and we start interpreting, we can look at the charcoal. The charcoal gives you an indication of what vegetation there was just outside the cave.
Yeah.
Why? Because nobody's going to walk for miles to get some bushes. You're going to get the ones that are just outside the cave.
Yeah.
So the charcoal is, if you like, an indication of the small-scale vegetation in the area. We have other ways of finding out what vegetation was at a larger scale. And the way we do that is we look at pollens. And we can get pollens from various sources. Well, one of the ones that we use is the pollen that we can extract from coprolites, which is fossilized droppings.
Right.
So if I can show you a coprolite.
Yeah, absolutely, we've got to see this. We have paleo poop here.
So following this level of charcoal, it comes all the way, we can see it, trace it all the way along. And follow it along through here, and you come to this level. It's still it's the same level, it's just slightly higher because it's on another part of the same dune. And then this white thing that you see here, that's the fossilized droppings, or the coprolites.
Okay.
Now, when you get the pollen, you can extract the pollens from the coprolites. What you're getting is, you might ask, well, okay, first of all, what produced that coprolite? Well, we're fairly certain that's a hyena that was probably rummaging around the remains of this fireplace, see if they could scavenge anything was left. But that hyena would have been feeding on herbivores that are in the plain outside, and those herbivores in their own right have a range. So when the hyena eats the guts from this herbivore and ingests the pollen that herbivore has been eating, we're getting now a sample which is on a larger scale. So now we can build up the picture of the landscape, what there is on the large scale from the pollens, what there is on the smaller scale from the charcoals.
So let me ask a sort of a naive question. How often do you find things like this? I mean, is this a totally unique thing in this context, or every so often you have this kind of evidence?
You do find coprolites on I would say on a fairly regular basis. I wouldn't say that the place is awash with them, but you do find them from time to time. Usually where you get hyena activity, you don't get human activity.
Yeah.
In fact, it's very rare that you see them together. What you do find is that the hyenas will come in after the humans have left, probably to see what they can find.
It's fascinating because there's a whole science of this, right? You're talking about understanding what herbivores are eating because you can predict that the hyenas are going to eat what the herbivores already have in their gut. And it's going to show up in the coprolites. And we find, of course, human remains in certain coprolites in other contexts. And it's really fascinating. Okay, so let's walk around a little bit and see what else we've got here. Okay, so here we're looking at a much larger section of the entire site. And there's yet more because the site goes on, deep into the cave. But here we're looking at a very tall profile. So what have we got here?
Well, this is probably some 5 meters from the area where we were looking at, or maybe 6 meters from the coprolite. So it's above it as well, so it's more recent than that activity that was going on then. And what we have here is another cross-section through the dune. Because it's further into the cave, the dune is behaving in different ways as well. And remember, the dunes build up when it's very windy, and then when there's animal activity, and that includes people, the dune gets eroded, and so there's a constant flux in the dune. But in moments where the cave is unoccupied, then you get the dune building up. And this is why you get different bands of different types of sediment forming.
Right.
And what you can see here, and this is quite a large cross-section, is 1 to about 5 meters high. This just gives you a good section of the activity that may have been happening in the cave over the years. And what it shows you is that there's been people have been coming and leaving the cave continuously for a very long time. And you can see that in the different conditions of the sediment. So there are some sediments that are full of organic matter, organic material, a lot of charcoals, lithics, and then you get bands where there is an absence of those and there's a lot of sand that can be associated with a moment where perhaps it was cold and there was a lot of wind bringing in a lot of dune. And the dune was building up very quickly. Then maybe there's more rain and there's more organic material being washed into the cave, and so the sediments change in their characteristics, and these are the bands that are building up. And
so when we see color bands like this, and a lot of archaeological site profiles have this sort of look, you're looking at each of them representing a sort of a climate, a microclimate in a way. And that's the circumstances in which things are accumulating. And depending on the moisture content, depending on the carbon, what's getting into it, it's going to be different colored today.
That's right.
Yeah, okay.
And that's what gives you, and this is what you can then read.
Yeah.
And so when there are people who can specialize on that and look at the sediments and interpret based on what is in that sediment, what is causing the differences. And then that's how you can start building up a picture of what's happening at each event.
And of course, based on the total stratigraphy of them, taking an accounting of what there is, and using certain kinds of methods, we can sort of figure out how old things are.
That's right.
When we look in Gorham's cave, what is the oldest stuff that we know of now? Because you haven't gotten to the bottom, right?
No, we haven't.
Yeah.
Well, you have to use different dating techniques because 40,000 is probably about the barrier for carbon dating. So using the different techniques, we use uranium thorium, we use OSL, but all these different techniques at least give you an indication of what sort of ages we're talking about. So where we're standing is more or less about 40,000 years ago. That's just an idea.
Yeah.
But right at the very back of the cave, of course, you've got the sediments which have been associated with Neanderthal activity, which
Yeah.
are the most recent anywhere else in the planet.
Yeah.
The last Neanderthals were there. If you like, we can go and have a look at those in a minute.
Well, you know we're going there next, so. I like minutes like that, right? Because this is where the video now switches.
All right, so now we're in Vanguard Cave, and Vanguard Cave is a really relatively short stroll. I mean, we climbed over rocks to get here, but it's very close to Gorham's Cave, and yet this cave presents a different scenario in terms of what is going on in the deposit, what you're finding here. So describe a little bit about what Vanguard Cave is like.
Right, well, Vanguard in some respects resembles Gorham's. It's a sea cave, but the sediment that's filled it in, it's 17 meters, almost as much as Gorham's, which is 1 meter more, as far as I know now. Seems to have come in much faster. A lot of the sand dune activity is much more active. So that when you reach the top, and we're practically here at the top level, whereas in Gorham's you have Carthaginians and Neolithic, there's none of that.
Yeah.
It's all Neanderthal, right to the very top.
Yeah.
So we think that possibly a slight difference in orientation of the cave meant that the dune activity is more intense here, filled up, and what you seem to be getting here are repeated levels of more sporadic occupation, as far as we can see right now, by Neanderthals all the way to the top, and then periods of intense wind-blown activity, which seem to preserve moments very, very precisely. Gorham seems to, the industry, the way it's done, the intensity of the hearth seems to suggest it's like the mother cave, if you like.
Yeah.
They're living there quite continuously. Places like Vanguard, already around the corner, seems to represent moments.
Yeah.
People come in, they may collect shellfish and do something, or hunt something and come in and move out quickly. Because it's so exposed to the dunes, it's much more directly towards the dunes. The dunes quickly come and cover up these moments.
Right.
So what you seem to be getting here are almost very, very short-term events which tell us stories in the life of Neanderthal peoples and what they were doing.
So when we look at the profile here, we see that there are these very distinct layers of sand that have come in. The wind is blowing them in, from the east.
That's right.
And the dune is building up right against the rock.
Piling up.
And it's striking when you look further down the rock, the amount of sand.
Absolutely.
That is just totally sloped up against
just further along from here, there's a big sand dune,
Yeah.
a fossil sand dune, which runs up 300 meters.
Yeah.
Which is almost to the very top of the rock. So it's quite incredible how fast this activity, during the period we're talking about, which is isotope stage 3, 60 to sort of 30,000 years ago, there were moments here when aridity must have been really quite strong and a lot of wind-blown activity was happening. And you could see that recorded in the cave. Of course, what we don't know is that this kind of profile may well have been what Gorham's looked like originally before anyone excavated in the 50s.
Yeah.
And what we don't know is what's behind there.
Right.
Which is intriguing because the cave seems to be opening out.
Right.
And one of the things we want to do is to actually just go through those top levels next year and begin to see whether there is another chamber just like Gorham's has at the back, and that would be extremely interesting.
Right.
But for now what we have is the front end of the dune, if you like.
Yeah.
So we're just clearing the deposits and exposing these horizons, which you can see very clearly. Some had campfires, some have incredible preservation of water levels.
Yeah.
So again, we're talking about the importance of water. We know there were moments here when they had fresh water. And it's just absolutely incredible, the resolution it's got.
And this cave is by and large earlier than what you have so far at Gorham's Cave.
Yeah. The top here, we got 2 dates last year for radiocarbon, and they're on the limit, so it's 45 plus. So we've taken now samples for OSL dating, because obviously we can't use radiocarbon here. But what it means is that the top here is probably equates to the front area that we were looking at roughly in Gorham's Cave.
Yeah.
So a lot of things happened in Gorham's Cave after this one was already clogged up.
Okay. All right. So let's go look at the profile a little bit.
Okay.
What we're seeing in this cave is that the sand is blowing in and it's accumulating rapidly enough that you're really getting rapid burial of things, and that includes particular moments of time.
That's right. So in this cave, you're getting a very high resolution of events.
Yeah.
And events that might not necessarily be so far apart in time. And so you get a moment when maybe a short time span where there's quite a dry spell, and there's a lot of dune being brought in, the sand grains are being built up, and then there's a rainy episode, and so it gets a little bit of clay gets accumulated and sort of seals it almost. then if it's followed by a very rainy event, you might actually get water that's actually accumulating, and then we find the remains of little ponds, and we find in those ponds the remains of little amphibians and reptiles. So they've been around long enough for other animals to come in and colonize it briefly, and then it's over. And the dune comes over and wipes the slate clean, if you like, and covers it, and the whole process starts again. And these episodes could take days or could take years.
Wow. So here we've got this year's excavation that has gone on, and we have one of these sort of water little ponds that
right.
You've just uncovered here.
It's spectacular because, I mean, you can see exactly what it is because you see it today. You know, when the mud dries out in the summer, you get these sort of cracks appearing, and that's what you've got there. And then when those markers that you can see in red is where we have found bones that will need to be processed, but they'll be reptile and amphibian bones. You also get little specks of charcoals, but there's no evidence of campfires, obviously, where there's a pond, but that makes sense. But what it tells us is that the campfires may have been nearby, so that when the pond dries out, the little embers are blowing in with the wind together with the sand as it's all coming in.
Wow. I mean, it's for a non-archaeologist, you know, to imagine what archaeological deposits are like. You know, they're very different. Each one of them is unique in the way that it accumulates, and sometimes it's hundreds of thousands of years, and sometimes you get these really very short periods of time where you can interpret a lot about what happened at a particular time. What would you say is the neatest thing that has come out of that?
Well, this is the beauty of this cave. This cave gives you events that are maybe hours or days long at most. So we've got this group of possibly 2 individuals. They come in with a little bundle of mussels that they have foraged nearby on the coastline. We don't know exactly where the coastline would have been, but it can't be very far because you don't carry seafoods for very long because they spoil very easily. And they come into the cave, they build a very small fire. There's not much charcoal left from that fire, and there's not much alteration on the sediment, so there wasn't a huge heat on that fire. Probably just enough to open those mussels. They consume the mussels. Once they're there, they're retouching the lithics that they're using, their stone tools. They take those away with them when they go, but they leave all the debitage behind. And then that's it, you know, they've gone. So they may have stayed overnight, or it may have been, just a brief few hours. But the fact is, when they go, the sand covers it up, and it's left there untouched until we come along and we excavate it. And I think that's a huge resolution. I mean, that is unique, I think.
It's completely remarkable.
It's beautiful.
I mean, it is the closest that we come anytime in this to seeing what somebody's life is like.
Absolutely, yes.
You know? And that, I think, is just amazing.
It tells us a lot as well, because it tells us that they needn't necessarily have always been sitting around. You know, they move from place to place. They stopped temporarily, had a quick picnic, and then carried on, you know. And in this particular case, it was just 2 individuals. There's no evidence that it was any more than that. So, you know, it talks about how they're behaving, how they're exploiting the environment. Of course, we don't know what else was going on further out to the cave, but then that's what we do.
Well, we talk about logistical strategies. For hunter-gatherers, that's what this means.
Absolutely.
You know, we're using the landscape, and it is not you're sitting up in a home base and organizing parties of people to go do things, except once in a while. You know,
possibly.
when it might be.
But certainly on that occasion, it wasn't, and this is all we can say, but it's great. And the resolution is what speaks to us. And you see this here because all these little lines, that, you know, it reminds me of these ice cream cakes, that there's lines of ice cream and chocolate. And this is what you've got here. And it's not necessarily hundreds of thousands of years. We're talking possibly events which are as short as days. And in some cases, the geomorphologist assures us that it could be as short as hours. So that's exciting. I mean, that resolution is very exciting.
It is. It's amazing. So what is the strategy of, you have an ancient water feature in a sense, and you've exposed it, and you're going to study it, and so on. And you can just see in the surface here, there are these cracks. There are impressions of things, you know, that it is. You've got a unique sort of record, and obviously, if you want to go below it, you've got to destroy
it. This is the point about archaeology. It's destructive.
Yeah.
So you have to record absolutely everything you possibly can before you touch it. But like you said, there's imprints on it. We don't know what made them. It could be vegetation or wood that's rotted away and it's just left an imprint. But it shows that this pond wasn't here for just an hour or two. The ponds would have taken longer and they would have stayed around for longer. And if they were, you know, amphibians were finding them, then obviously they must have been around for a while. So once we've recorded everything that there is to record and we've taken all the samples that we can possibly take, what we tend to do is we preserve some of it. We take casts and we take the whole item is removed in one piece. In this particular case, because it's such a huge extent, we probably will only do it for part of it, which will be preserved. And we will preserve part of the level anyway. But then we have to go through it to see what's below. But we've done it already before, and these dark lines that you see against the section, that is where other ponds and puddles have been found, and we've had to work our way through them.
Okay. Wow.
The beauty is that amphibians are such wonderful indicator species. They're so fussy about the climate conditions that they can thrive in. So that helps us reconstruct the environments. I find that really exciting.